आवाज ठीक से सुनाई दे रहा है क्या?
यस सर।
Yeah.
सर लेक्चर्स मतलब कब तक चलेंगे? कुछ ऐसा बोला नहीं है सर ने डेडलाइन कि मतलब इसके बाद नहीं लेना है करके।
डेडलाइन नहीं बताया है, तो मैंने आपको बताया ना कि हमारा सिलेबस तो खत्म हो गया है, लेकिन हम लोग ट्यूटोरियल्स नहीं किए हैं ज़्यादा कुछ, तो अभी जब तक चलेगा तब तक हम ट्यूटोरियल्स करते रहेंगे।
ओके।
और अच्छा, एक सेकेंड। So I have shared the final internal marks of everybody. सबको दिखा क्या अपना अपना इंटरनल मार्क्स?
यस सर।
ओके। सूर्य प्रकाश है क्या यहाँ पे? अच्छा नहीं है। ओके, दैट्स फाइन। प्रिया है क्या यहाँ पे?
यस सर।
So Priya, you did not attempt the final long quiz, is it?
यस सर, एक्चुअली मेरे यहाँ पूरा मतलब बदलापुर के यहाँ पूरा लाइट गया था सुबह से लेकर के शाम तक, तो नहीं हो पाया फिर वो। और नेटवर्क भी नहीं आता है मेरे एरिया में, तो मोबाइल नेटवर्क का कुछ काम नहीं था।
ओके।
और उसी दिन फिर पूरा पावर कट हुआ था, शाम तक हुआ था, तो इसके लिए मैं नहीं दे पाई। बाकी मैंने सारे दिए हैं, बट सॉरी ये नहीं हो पाया लास्ट वाला।
हाँ, वो मुझे दिख रहा है यहाँ पे। I was just looking at the mark sheet because this was probably, if your final exam is online, then this was good practice for you, इसलिए।
यस
Any-
सर, एक्चुअली मतलब बैकअप के लिए मुझे फिर कुछ ना कुछ देखना पड़ेगा।
हाँ, मतलब अभी मेरे पास फिलहाल दोबारा एग्जाम करने के लिए समय तो नहीं है, so you will have to manage.
यस सर, सॉरी सर।
No problem. Yeah. Code all right from the previous quizzes, so it's okay. सूर्य प्रकाश है क्या यहाँ पे? सूर्य प्रकाश भी नहीं है। ओके, एनीवेज, सो लेट अस स्टार्ट।
सर ये वाला जो लॉन्ग क्विज लिया था, मतलब वो फाइनल्स में कुछ काउंट होगा क्या? ऐसा है क्या?
आपके इंटरनल्स में काउंट हो रहा है ना ये?
हाँ मतलब, तो अभी तो वो
बस
जो इंटरनल्स दिए फाइनल है ना, या फिर और भी कुछ करना है उसमें?
इंटरनल्स का नहीं, टोटल 100 में 40 मार्क्स आपका इंटरनल्स है, उसमें ये काउंट हो रहा है, जैसे कि मैंने आपको बताया
हाँ
है। मतलब जैसे आपको अभी फाइनल वो इंटरनल का शीट में दिख रहा है, वही है
हाँ।
आपका। उसके
ओके
अलावा कुछ और अलग से काउंट नहीं होने वाला।
ओके, फिर वो एक्सटर्नल्स का वो तो खुद होगा अभी जो फर्स्ट फेब
और जो
से, वही
फाइनल
रहेगा।
एग्जाम होगा उसमें से ही।
ठीक है।
Alright, so let's begin. So now, as I said, now we only have problems to solve one after the other. Okay, so uh, what I want you to do is, spend time. जैसे हम प्रॉब्लम करते जाते हैं, go on reading the related stuff, so that will also be good preparation for you. If you have not covered up something, this is also a good chance to study that, because now we are only solving problems. So as and when you solve problems, you can read and understand and study the remaining parts. All right. So I hope you all have the tutorial sheets. Let's pick one of them. So all right. So share screen करते हैं. So are you able to see the screen?
Yes, sir.
So tutorial 7 is, I just wanted to say that, so look at the 3 questions here. Okay, take any 3 undirected graphs, each on at least 10 vertices, and produce the output of BFS and DFS. ठीक है, दोनों करना है. And take any 3 acyclic directed graphs. You understand, right? DAG, directed graph, but without cycles, without directed cycles. On each on at least 10 vertices, and produce a topological sorting. And then we have seen how to produce topological sorting. So you have to do the version of DFS on directed graphs, and you can do that because the graph is acyclic. All right, and then that will give you topological sorting. So that is what you have to do. Third one is take any 3 undirected graphs. Okay, again on each. So you can take whatever 3 graphs you take in question number 1. You can take the same thing. And now you have already given the output of BFS anyways, but you have to do more now. You have to compute the length of the shortest path between at least 3 pairs of vertices. So you have to take 3 pairs, A1, B1, A2, B2, A3, B3, and find the shortest path between A1 and B1, A2 and B2, A3 and B3 for each of these 3 graphs. All right. So this is very much similar to what you do in question number 1, but the difference is when you want to find the shortest distance between A1 and B1, your BFS has to start from either A1 or B1. It cannot start from some arbitrary vertex. That is the only main difference. Okay. Now, as far as sorry, as far as our unit, the last unit on graph algorithms goes, this is all there is in the last unit. Okay. So in तीनों का, I think we have done 2 to 3 examples for each already. All right. So this tutorial I don't want to repeat. I don't want to keep doing this again and again when we are meeting like this. Okay. So I'll do something. Today I will post, if you want, I will post some 3 to 4 graphs. Okay, on MS Teams. I'll post the diagrams for 3 to 4 graphs. I'll upload it as a PDF file or something like that. You're supposed to try these before the next time we meet. Okay, you're supposed to try this before the next time we meet, and then again, I will not spend time. I'll upload the solution later on. Is that okay? So the main point is tutorial 7 is technically complete. We have already done these multiple times. For some more practice, I'll give you some more graphs. I want you to practice on your own before we meet the next time. Is that all right? So will you do that?
Yes, sir.
Okay, so tutorial 7 is in that sense complete. That's all. इस unit में और करने के लिए है नहीं कुछ. Okay, this is all we have here. All right, so let's go to tutorial 6. Okay, I'll take it in random order. So let's do tutorial 6. All right, so tutorial 6 is on greedy algorithms. Okay. For greedy algorithms, we have actually seen 2 examples. One is this activity selection problem, and the other is about unit distances, if you remember. Okay, so anyways, we have seen in detail the activity selection problem. The unit distance problem here, I have written it once again as a question. Okay, so question number 3 is already solved in the lecture. If you look at the lecture where I explained unit distance problem, this has already been explained. Okay, So question 3 is done in that sense, but you still have to write the algorithm. So we will do that. Activity selection, and then there are 2 more problems which you have to think about. Is that okay? So let us start. And all right. So question number 1. So जिसके पास PDF है, you can open that, and others can look here. But I will switch to the board quickly. Okay. So finally we have to do things here. So you will not be able to see the questions all the time. So if you have the PDF with you, very good. Okay, so let's think about question 1. The activity selection problem. So what is it? It's a set of activities. Let's say n activities. Each of them has a starting time and finishing time. And you're supposed to cover as many activities as you can while making sure that the activities do not overlap. Is that right? So everybody remembers the activity selection problem? Well, if you don't remember, then go back to the lecture and revise. Okay. Anyways, this thing is being recorded. So I don't want to repeat what activity selection problem is. You know what it is. I'm going to assume that. All right. So suppose that instead of always selecting the first activity to finish, okay, so just go back and check. What we were doing was the greedy algorithm was by looking at the finishing times. We were assuming that the finishing times were first of all increasing. F1 less than or equal to F2 less than or equal to Fn, that way. Okay. And then we were prioritizing. So we will choose first the activity whose finishing time is the smallest, is the earliest. Then the next one which does not overlap with it and finishes the earliest. Then the next one which does not overlap with the previous two and finishes the earliest. That is greedy algorithm for activity selection problem, right? So now this is a variant. Suppose that instead of always selecting the first activity to finish, we instead select the last activity to start. That is compatible with all the previously selected activities. All right, write a greedy algorithm to do the same. Is that okay? So let's go to the board and then look at what this is saying. Right. So this is tutorial 6. Greedy algorithms. Question 1. So once again, as you have seen the previous things, I will explain the problem in detail. Okay. And then depending on the time, sometimes the main formal algorithm, I will put it as a recording. Is that okay? As I've done before for sorting algorithms and so on. Okay. So here I will explain the problem and its answer. Then you spend some time in trying to write the formal algorithm on your own. And in 1 or 2 days, I will put up the formal algorithm separately. Okay. So we have n activities. Let us give them a name. A1 to AN with starting times S1 to Sn and finishing times F1 to Fn. Okay. Now in the lecture, in the usual setting, so in the usual setting in the sense what we did in the lecture, okay? We assumed F1 less than or equal to F2 less than or equal to All right. SIs may be or may not be in order. It depends on how long the activity is. Okay. So that we cannot be sure about. Here, what we will do here, we assume S1 less than or equal to S2 less than or equal to. Okay. And the finishing times could be in different order depending on the length of each of the activities. Okay. So this is the assumption that we make. This is the first thing. Now, how do you want to do the algorithm, the greedy process? So let's go back to the question. This says, instead of selecting the first activity to finish, we instead select the last activity to start that is compatible with all previously selected activities. All right. So then what this does is, I'm sorry, not here. Yeah. So we will first choose the last activity to start. Okay. So then the algorithm basically does this. Algorithm, I'm calling it outline because I'm not writing the formal algorithm. Formal algorithm I'll write it later on. Okay. Last algorithm to start, sorry, last activity to start here. So the finishing time is Sn, which starts the last one, right? So the last activity to start is An. So choose An. First step is choose An. Right? And then this next step is among the AIs I not equal to N. What do you do? Choose I such that Si is largest possible and there are no overlaps. You understand? So for instance, you will first look at Sn minus 1 and An minus 1. Then you will see that, well, An minus 1's interval clashes, overlaps with the interval of An. So then you cannot choose An minus 1. You will have to go back to An minus 2. You have to look at the interval of An minus 2. That might also intersect. Then go to An minus 3. Its interval is the first one, which does not intersect with the interval of An. So then you will choose An minus 3 and then you will repeat. Okay. So you're doing it in the reverse fashion in some sense. You're doing it in the opposite way. Okay. Then the third is repeat until all activities have been checked. Okay, so this is the algorithm outline. Very, very simple greedy algorithm. Exactly the same thing as you did in the first case in the usual setting, but in a reverse fashion. Instead of looking at finishing times, you look at starting times, and instead of starting with the first activity, you start with the last activity and then go backwards. Okay, that is it. There is nothing more that you have to do. So I think we have written the formal algorithm in the first case. Just look at that and look at this outline, this explanation that I have given, and write down a formal algorithm. Sorry. Write down a formal algorithm for this case also. Where it's going to be very, very, very similar. Okay. It's not going to be different. All right. So yeah, I will stop this question here. Let's go to the next one. All right. So next question. So by the way, if you think that I'm going a little fast, it is because, well, since anyways, we are not discussing much and I am giving you hints to solve the problem and explaining how the problem is to be solved. you can go back to the recording, pause and think about it more when you write down the formal algorithm. Okay, that's why I'm going a little bit faster. And we have lots of problems to cover also, so that is good. Okay, so now question 2, suppose that we have a set of activities to schedule among a large number of lecture halls. Okay, this is exactly your timetable problem. You understand? आपके college में there are so many classrooms. Lecture halls are classrooms. Your activities are your lectures. You have so many courses. You attend what, 5 courses? And then each of the 5 courses has, 3 lectures or 4 lectures every week, or 5 lectures every week, whatever it is. And now your college can run only from certain time to certain time. अभी online है इसलिए कुछ भी चल रहा है, but if your college was running physically, if you were going to physically to college, you will not have a lecture at 7:30 in the evening, no? You can only have lecture from something like 8 o'clock in the morning to 2 o'clock in the afternoon, or maybe 5 o'clock in the evening, but not beyond that, right? So you have those timing restrictions. Therefore, you have only so many hours that you can spend in the college in a particular day. But you have so many courses. You have 5 courses, and you have to have whatever 6 lectures for each of those 5 courses every week. So now you only have so many classrooms in your college, and there are so many other batches. Your MSc Part 1, there are other batches, right? BSc वाले हैं, commerce वाले हैं, arts वाले हैं. Everybody has access to the same college, right? So this is the timetable problem. Now you want to manage your schedule in such a way that everybody is able to attend every lecture every week. So you have to fix a timetable. Okay. So suppose that we have a set of activities to schedule among a large number of lecture halls, where any activity can take place in any lecture hall. So there is no restriction, okay? There is no classroom particularly reserved for science or particularly reserved for physics students, nothing of that kind. Every classroom is the same. Any lecture can happen in any classroom. That's the idea. Okay, so any activity can take place in any lecture hall. We wish to schedule all the activities using as few lecture halls as possible. Okay. Give an efficient greedy algorithm to determine which activity should use which lecture hall. All right. So do you understand that this is some sort of an activity selection problem, first of all? I mean, you have to give slots to activities, so definitely this is some sort of an activity selection problem. Is that okay? So,
Yes.
so just think about it for a few minutes. How will you approach this? It is not the same as the previous problem. There are some differences. Try to understand the differences. How will you approach this? First thing you have to do is when you have a problem that is given in words, you should introduce symbols. So there are n activities, let's say A1 to AN. There are some number of lecture halls H1 to HK. And then the activities will have starting times and finishing times, SI, FI. In this case, these are lecture halls. So you can assume that every activity is of 1 hour duration. So SI and FI are related as follows. FI is equal to SI plus 1. That much you can assume. Okay, 1 hour or something. Beyond that, how will you do this? See, note that the activities are there, but there are also lecture halls now. Okay, that is something to think about.
प्रेम का मतलब ये नहीं है
All right, so let's do this. So as I was saying, the important point here is that in addition to the activities, you also have lecture halls. Okay, so question number 2. Suppose we have activities A1 to AN with again the same thing. Okay, so starting time S1 to Sn and finishing times F1 to Fn, and let's assume that as before F1 less than or equal to F2 less than or equal to Fn. Okay, so we will do this for this convention, and as we saw in question number 1, you can also try to do the same in the alternate case where you don't restrict FIs, instead you restrict S1 less than or equal to S2 less than or equal to Sn, but then you will have to do it in the reverse fashion. Okay, so that applies to any activity selection problem of this kind. Okay, there is always a dual way of doing it. Instead of finishing time, look at starting times and start from the back end. Okay, do it in the reverse. That will always work. Okay, so you can try that on your own. I will do it for this case. We will assume that F1 less than or equal to F2 less than or equal to Fn, and I'll start from the first activity. Is that okay? Further, what do we have? In addition, we have lecture halls. Let's call them H1 to some HK. Okay. Now you have to allot activities to the lecture halls. Okay. So how do you do this now? Now this is very simple. Algorithm. Okay. So the first step is the following. You are basically doing the same thing as before multiple times. Okay. So let S be equal to the set of activities S1 to Sn. Okay. Just fix the lecture hall H1. Okay. Oh, one second. So one more point here is, here every Fi is equal to Si plus 1. So yeah, you don't have to do the dual, because then, so therefore S1 is less than or equal to Sn. Okay, so yeah, the dual will give you the same answer actually in this case, because of this relation. Okay, so yeah, so fix hall H1, and now the same thing, perform activity selection on S for hall H1. You understand what I'm saying? What am I doing here? Find the activity that finishes first, allot that to the hall H1. Then you look at the remaining activities, find the activity that finishes first without overlap among the remaining ones, again allot it to H1. Okay, so assume that you only have one lecture hall, then it is your usual activity selection problem that you have seen before in class. Okay, so keep on doing this activity selection problem for this fixed lecture hall H1. Okay, so what will happen? Let S S prime be the set of activities in S allotted to H1. You understand? When you do this, depending on the finishing times, some activities from S will get allotted to the hall H1, right? But some activities will remain. These are the activities which have had overlaps, and therefore you could not allot them. Okay, so you have S prime to be the set of activities in S which got allotted to H1 when you did activity selection. Okay, which activities remain? The activities that remain. So I'm changing S to S minus S prime. You understand? You start with S, the activities which have already been allotted, remove them and put it back to S. Now what all activities are in S? The activities which are remaining to be allotted. Okay. Now repeat step 1 for hall. Which hall? H1 का हो गया, H1 has been allotted. For hall H2, H2 is free right now. Okay, now do the activity selection for H2. Some activities will get allotted to H2 among the remaining ones. Okay. Further, still some activities might remain. If they remain, you go to H3 and then you allot those. Okay. So the final thing is repeat for H3 to HK. Repeat what? Repeat steps 1 and 2. You understood? This is just a repetitive activity selection. You did activity selection once, but for the first hall. Then from the remaining activities, you do activity selection again for the next hall. Then from the remaining activities, you do it again for the next hall. And you keep doing that until all the halls are, or until all the activities are over. Okay, so you will, there is a small chance that H1 to HK, even after HK, some activity remains, but we will not think about it. We will assume that everything can be slotted within H1 to HK. Okay, nothing will remain at the end. That's an assumption. That is okay. All right. So is this idea clear to everyone? Repeated activity selection for different lecture halls.
Yes. Yes, sir.
Okay, so that is it. That is the greedy algorithm that you have to do. Again, spend some time and try to write it down. Now it is basically, so you can take the algorithm of activity selection from the lecture that we have seen, use that as a function inside your main algorithm, and you can repeat it. Okay. All right. So question number 3. किसी का mic चालू है, please off कर लो. So okay. Question number 3. Describe an efficient algorithm that, given a set of points x1 to xn on the real line, determines the smallest set of unit distance or unit length closed intervals that contains all of the given points. Okay, we have already seen this in class, but let me just repeat it quickly. Okay, now here I'm not going to assume that x1 to xn are increasing. So can you tell me what will be the first step? If x1 to xn are in some order, okay, we don't know what order it is. They are given in some, just as a set. If you can recall what the unit distance problem is, how you did it in class, then can you tell me how you will handle this thing? What will be the first thing that you do?
सर डिवाइड किया था ना हमने इंटरवल्स को.
डिवाइड नहीं किया था, अलॉटमेंट किया था, बट मेरा कहना यह है कि x1 to xn are not increasing. You don't know that x1 less than x2 less than xn. In that case, how will you start? Greedy algorithm के लिए order बहुत important है ना. You first allot. You started from the interval x1 to x1 plus 1. That is how you started.
तो फिर पहले अरेंज करेंगे, देन उसके बाद फिर एल्गोरिथम स्टार्ट करेंगे.
अरेंज करने का मतलब क्या है? मतलब अरेंज इस लेवल पे कोर्स इतना पहुंचने के बाद you should not use the word arrange. What is the correct word?
Sort.
Exactly. You have to sort it. Okay. So you should get used to the new things that you learn. Okay. वो सीख के भूलने का नहीं है. वो आगे भी काम आएगा. बार बार काम आएगा. Okay. At this level, you are not supposed to use the word arrange. You're supposed to say sorting. Okay. So yeah. So that is the first step. Question 3. So given, so this is again algorithm outline. Okay. So let x is equal to xn. What do? The first thing you do is let y be equal to some sorting. Okay. I don't care what sorting. You can quick sort, merge sort, वगैरह वगैरह जो करना है करो. So I'll just say sort of x. That's equal to, let's say, let us give it some new notation, y1 less than y2 less than yn. Okay. Now you are going to do this. Now you are going to work with y. You're not working with x. You will just work with y. Okay. You have sorted in increasing order. So what is the first thing you do? Let the first interval you choose unit distances. Okay, that's the first thing. All these intervals have unit distance or unit length. Length is always 1. Okay. So let I1 be the interval y1 to y1 plus 1. Right. What is the next thing you do? Find the, okay, so let me write down in step numbers. So step 1, step 2, step 3, step 4 is find the minimum I such that yi does not belong to I1. Right? This you can do just by looking at this. Right? When will y2 belong to I1? When y2 minus y1 is less than 1. y3 minus y1 less than 1. Just subtract, look at the distance. That's all. Okay. The distance between yi and y1 should be, that is, so when it is not here, this is exactly saying yi minus y1 is greater than or equal to 1. So this is what you will check in the algorithm. You understand? Although what we really want to do is find the minimum I such that yi is not belonging to I1. The way to check this is by looking at this condition, little yi minus y1 greater than or equal to 1. I hope you understand. It's the same thing. Okay. Find the minimum such I and let I2 be equal to, you start from this point, right? yi to yi plus 1. So this is the new interval that we choose. Okay. Then what you do, repeat step 4 for remaining wedges. That's all. Okay. Repeat step 4 for remaining wedges. So you will have to put it in a loop or a while loop or a for loop, something like that. Now I leave it up to you to think about it and decide what loop you have to choose. Okay. So think about the formal algorithm, how it is. But this is the outline. These are the basic steps here. Okay. So is this algorithm clear? The idea clear? What you have to do? I mean, I have just repeated what we did in class, but once again, is it clear to everyone? Okay, so That is all there is actually. So the smallest set of unit length intervals is okay. So the final step anyways I'll write. Return the set of intervals. Chosen. Okay, you have to also give that as the output. I1, capital I1, capital I2 up to some capital IK, whatever it is. All right. So next question.
सर
हाँ बोलो.
सर वो बोर्ड दिखाइए ना एक मिनट डन सर.
Okay. Okay. So now question number 4. Okay. Now, if possible, I will try to give you more greedy algorithms. For the moment, I only have 4. Okay. So these are the problems that are there in books, but I hope you get enough practice just by looking at this. So yeah, you're given two sets of integers, capital A and capital B. Okay. The ordering is not decided beforehand. It's just a set of n positive integers each. Each one has n positive integers. You have to choose. You can choose, but in fact you have to choose to reorder each set as you like to obtain the orders A1 to AN and B1 to BN. Okay. Now this is not increasing order, decreasing order. That is not the meaning. The meaning is you have to tell which is the first element, which is the second element, which is the third element. Okay. That is the meaning of saying A1, A2, A3 up to AN. Okay. So that's the ordering you're fixing. You're saying which one is the first element, which one is the second element, and so on in each set. So you have to find out that ordering. Okay. So for any such ordering, if you fix this order, then you get a payoff. Payoff is like some amount of money that you're getting. If you give me an ordering for A and B, I'll give you some money. Okay. So if you give me the ordering A1 to AN for capital A and B1 to BN for capital B, the money I will give you is the amount product AI raised to BI. So A1 raised to B1 times A2 raised to B2 up to times AN raised to BN. I'll give you that much money. So what is your aim? Your aim is to fix the ordering A1 to AN or find the ordering A1 to AN, B1 to BN such that the money that I have to give you is the maximum possible, right? पैसे का मामला है. You have to maximize. Okay? Is the question clear to everyone? Is it so difficult to understand? Hello, can somebody tell me if you did not understand this, what is it that you did not understand? Simple सा बात है. There are two sets of numbers. You will decide what is the order of the set of numbers for each set. Depending on that order, I'll give you certain amount of money. You have to maximize the ordering. You have to fix and find an ordering such that the amount that I have to give is the maximum possible. Is it so difficult to understand? कोई है या नहीं है? आप लोग हो ना यहाँ पे? Why can't you just give me an answer? Okay, so how will you proceed with this? Note that this has to be a greedy algorithm. Greedy means you have to try to maximize and maximize and maximize right from the first step. चलो एक एग्जांपल देखते हैं. ओके, आई मीन दिस इज लिटिल डिसअपॉइंटिंग. हाँ, मतलब ये सवाल भी अगर आपको समझ में नहीं आ रहा है तो इट्स रियली डिसअपॉइंटिंग. So if I give you sets of three numbers, 3, 1, 2, b is equal to 5, 1, 3. Can you tell me what ordering you will pick so that you get maximum possible amount? If you have to be greedy, how will you start?
लार्जेस्ट नंबर लेंगे पहले.
कहाँ पे? कौन से सेट का लार्जेस्ट नंबर? आधा अधूरा नहीं बोलने का मतलब गिव मी फुल कंप्लीट योर.
सर वो क्वेश्चन ही नहीं समझा, मतलब
अरे
नहीं
मैं
समझ.
हिंदी में बताया कि मैं आप ऑर्डरिंग बताओ, मैं पैसा दे रहा हूँ. अब इसमें समझने में क्या बाकी है? आई मीन
कोई भी ऑर्डरिंग चलेगा फिर.
अरे पैसा तुमको चाहिए ना, पैसा मैक्सिमाइज करने का है ना तुमको, तो कोई भी ऑर्डरिंग कैसे चलेगा? ऑर्डरिंग तुमको ढूंढना है ना, ताकि तुमको सबसे ज्यादा पैसा मिले, ज्यादा से ज्यादा पैसा मिले. That's what I've been trying to say, right? When
यस
I
सर.
say find an ordering that maximizes the amount you will get, इसका हिंदी समझ में आता है क्या? मतलब do you have real trouble in understanding when I say things in English? These are
नो
simple
सर.
sentences, no? So what is the problem? आप लोग एक काम करो, ये प्रॉब्लम खत्म करते हैं एंड वील टेक अ ब्रेक ऑफ 10 मिनट्स. चाय कॉफी जो चाहिए पी के आओ. आई मीन दिस इज शेमफुल इफ यू आर नॉट एबल टू अंडरस्टैंड इवन दिस क्वेश्चन. ये ऐसे नहीं चलेगा. फ्रेश होके आ जाओ, 10 मिनट 15 मिनट ब्रेक लेंगे इसके बाद, ठीक है? बट ऐसा नहीं चलेगा. थोड़ा और कॉम्प्लिकेटेड है, कुछ मुश्किल है, कोई नया कंसेप्ट है, ठीक है, आपने पहले देखा नहीं है, समझने में मुश्किल हो रहा है. मैं हिंदी में समझा रहा हूँ फिर भी आप लोग समझ नहीं रहे हो. आई मीन something really problematic. Okay, so anyways, now when I gave you this example, you're able to see, right? So what will you do? Maximum कहाँ पे?
सेट के अंदर ही देखेंगे हम सबसे
कौन
मैक्सिमम.
सा सेट? दो सेट है यहाँ पे.
ए और बी, पहले ए का करते हैं फिर बी का देखेंगे. तो ए में मैक्सिमम 3 है.
Okay, then
देन 2, देन 1.
okay, so let's give the ordering. Let's call this A prime 3, 2, 1. Okay, and then what will you do?
Then we'll do ordering of B. That is 5, 3, 1.
Okay, तो इससे पैसा क्या मिलेगा?
सर वही तो नहीं, मतलब क्या पैसे नहीं, मतलब समझ में नहीं आ रहा पूछ क्या रहे हो करके.
अरे यार, इसका मतलब क्या है? What is this quantity? If you give me this ordering, I'll give you this payoff. This is the payoff. Payoff matlab something that you get, some reward, some amount, something. Its value is this product. इसका मतलब समझ में आ रहा है?
हाँ.
हाँ. यहाँ पे क्या मिलेगा आपको? Three raised to 5 into 2 raised to 3 into 1 raised to 1. That is equal to something. I don't even care what that number is. मेरे को इतना मिलेगा. This is the payoff. Is that okay?
Yes sir.
What is your difficulty? अब ऐसे चीजों का जवाब नहीं दे पाते तो मुझे लगता है कि आप लोग ध्यान ही नहीं दे रहे हो. आर यू इवन हियर व्हेन आई एम एक्सप्लेनिंग? दैट इज द डाउट आई एम गेटिंग, कि ऐसे ही माइक बंद करके आप कहीं भी चले जाते हो. Okay, so do you realize that when you do maximum, you have to pair them. maximum of A raised to maximum of B. Then second maximum of A raised to second maximum of B. Third maximum of A raised to third maximum of B. When you do this, you will get the maximum possible amount. Is that clear to you?
Yes, sir.
You take these powers in any other order, the value is going to be less than this. This is the maximum payoff. This is the maximum payoff. Okay. So now in general, what is the algorithm? In general, what will you do?
First of all, we will do sorting, like ordering करेंगे पहले.
कहाँ पे?
सेट्स के अंदर जो भी हमने सेट्स लिए A and B सपोज लिए, तो उसमें ऑर्डरिंग करेंगे.
Okay, and then उतना ही करना है. Do you realize you only have to give the order? This
फिर
amount fixed. The algorithm has to give an order that will maximize. So that's all. Let A prime, so more generally let A prime equal to, use a sorting algorithm on A. Second step, let B prime use the sorting algorithm on B. Third, there is nothing more to do. This is the answer. This ordering will maximize the payoff. Okay, so just calculate the payoff. Compute the product I going from 1 to n, A prime I raised to B prime I. That will be the payoff in this case. Return A prime, B prime, and this value and the payoff. That's all. This is the payoff. This value is the payoff. Simple algorithm. Greedy algorithms are always simple. Greedy algorithm का मतलब ही है कि सबसे obvious जो चीज है वही करना है, ज्यादा दिमाग नहीं लगाना है. Whatever is the most natural thing that you will try to do, that is what you do. There is not too much of thinking about it. That is why it's a greedy algorithm. You try to be greedy. You do the thing that occurs to you to be the best choice just by looking at it. That will be the answer. That is the meaning of greedy algorithm in some sense. Okay. So that is the end of this tutorial. So let us take a break of 10 minutes or so, and then we will continue with some more problems. Okay, so take a break of 10 minutes and we'll come back. And come back fresh, please. Okay, come back fresh. Okay, so I'll stop now. Okay, so am I audible? Am I audible? Hello. 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 Am I audible?
Yes, sir. Yes, sir.
Yeah. Okay. So let's see how far we can. Okay. So all right. So first one is supposed to be easy. Now let's go to tutorial 5. So I'm going in the reverse for some reason. There's no particular reason, but I'm just going in the reverse. Okay, so now we will talk about divide and conquer and dynamic programming algorithms. Okay, we saw greedy algorithms earlier. Now we will look at divide and conquer and dynamic programming. Okay. So if you remember when we looked at divide and conquer, one of the examples was the maximum subarray problem. Okay. So I hope you remember what the maximum subarray problem is. You are given an array. A subarray is a consecutive set of indices of that array. Okay. A subset, but consecutive. And for each of those subsets or subarrays, you have a sum of the entries, and you want to find the maximum possible sum of among all the subarrays. Okay, that's the maximum subarray problem. There is another version where you not only find the maximum possible sum, but you also find the array which gives you the maximum possible value. Okay, so this is that variant. Okay, this is a variant. This is not recursive. This is not, it's a divide and conquer problem, but this solution is different. This is not divide and conquer solution. This is a different solution. But in addition to the maximum value of the sum, you will also be able to say which array, or well, even the other one you can modify. So you will be able to say which array gives you the maximum possible sum. Even the previous one we were saying which array is giving us maximum sum. Sorry, that was a mistake. Yeah. So we will find out the maximum sum array, but in a different way. Now it's not divide and conquer. Okay. But this algorithm is somewhat quicker because it's a linear time algorithm. This will run faster. Okay. So the question is the following: write a non-recursive linear time algorithm for maximum subarray problem using the following ideas. So what is the idea? Start at the left end of the array. Okay. The first element. Progress towards the right, which means you're going to go from right to left, keeping track of the maximum subarray seen so far. Okay, so from the first element you will keep going right, and for that growing array you will find the maximum subarray and you'll remember what that subarray is. Then knowing the maximum subarray of a1 to j for some j, you can find the maximum subarray for a1 to j plus 1. That is the idea. Okay, so here's the thing. So tutorial 5, and this is divide and conquer, and dynamic program. Okay. Okay, so so once again I'll give you the idea of what we are doing. Okay, so given the array A1 to N, okay, start with just A1. For this, the maximum subarray is just A1, right? Because there is only one value, A1. So the maximum subarray is also just A1. Okay, so this is the first step. Now, suppose, so this is how you will do the induction. For j greater than or equal to 1, we know the maximum subarray of A from 1 to j. Okay. The first j elements, when you look at it, what is the maximum subarray? Suppose you know what this is. Okay, so let's call this, say, A. So we will use this notation, right? Lj to E, sorry, from Lj up to Uj. Okay, Lj is going to be greater than or equal to 1, Uj is going to be less than or equal to j. That is clear. Okay, that is what it is. Now here's the idea, right? So you have up to some j, you have j plus 1, n is far away. Suppose you know that a subarray here is from Lj to Uj. What are the possibilities of maximum possible subarray for 1 to j plus 1? The idea is it is either Lj to Uj itself. Okay, if the subarray does not include j plus 1, aj plus 1, then the subarray is Alj to Uj. But if it includes if it includes the j plus 1th element, then it's a segment that is starting from some k to j plus 1. Okay, that is the idea. So step 3. Here's the thing. Find let's call this t. The t will be somewhere from 1 to j plus 1, such that a t to j plus 1 has the maximum possible sum from among which of these? Okay, so you have to find t naught, sorry, so t naught from among all these, from among arrays of the form a t to j plus 1, where t varies between. Okay, so t varies from 1 to j plus 1, and you have these intervals 1 to j plus 1, 2 to j plus 1, 3 to j plus 1, 4 to j plus 1, and so on. You find the t naught such that the sum of the elements from a t naught to a j plus 1 is the maximum possible among the sums of all these arrays. Okay, entries could be negative, so the maximum need not be for 1 to j plus 1. It could be in between. All right, and now what is the fourth step? Just compare the sum of a Lj to Uj with the sum of a T naught to j plus 1. What does that mean? If sum of a Lj to Uj is greater than, so let me put it in bracket, sum of a T naught to j plus 1, then a Lj to Uj is a maximum subarray of the larger interval a1 to j plus 1, not just a1 to aj. Else the other one, a1 to, sorry, a T naught to j plus 1 is maximum subarray of a1 to j plus 1. This is what you do, and then what do you do now? Finally repeat for all j. Okay, so finally when you go j equal to n, the subarray, the maximum subarray that you get, that is the maximum subarray of a1 to n. That's it. Okay, so you start from just the first element, then the first two elements, first three elements, first four elements, and you build and you go on finding the maximum subarray for each case. At the end, you will have the maximum subarray of a1 to n. Okay, so that is the idea. All right, a very similar idea. You're just comparing, but the way you are finding the subarray is slightly different from what we have seen before. Okay, so yeah, that is this. Go through this again and try to write down the algorithm, and then I'll give you the formal algorithm after a few days. Okay. Let's look at the second one. Second one is a nice problem. I think you might have seen a little bit of this in the long quiz also, where I asked you to find the runtime. But if you have to find the runtime, then you should also understand how it is to be done, right? So let us solve this problem now. So anybody who found the answer to this in the long quiz? Let's look at the first question. First sub question. Using Straussen's algorithm, write an algorithm to multiply a kn by n matrix by an n by kn matrix. Yes. So let's look at it. Okay, so what does it mean when you're multiplying a kn by n matrix by an n by kn matrix? So multiply, what is it? Kn cross n by n cross kn matrix. So do you see when you have kn cross n matrix, so we have, let's give them some names, okay? Let's call it A. What does it mean? There are kn rows and n columns. So I can write this as, I'll have to form blocks, right? So I can write this as A1 to AK and B is B1 to BK, where each AI and BJ is an n cross n matrix. Is this much clear to everyone? This block division. If there are kn many rows, then you can partition them into k blocks of n rows each. If there are kn many columns, you can partition them into k blocks of n columns each. That is what you are doing here. Is this much clear, everybody?
Yes, sir.
Okay. So now how will you multiply? Then what is AB? As a block formula, what is AB? Can somebody tell me? What is AB? What will be the order of AB? Kn by Kn cross n by n cross Kn. So the final matrix is going to be Kn cross Kn. Okay. And then this is going to be A1 times A1 times B1, A1 times B2 up to A1 times BK. Continue. Sorry. You continue, then AK times B1 up to AKBK. Is this clear, everybody?
Yes, sir.
So what is the algorithm going to be? You are supposed to use Strassen's algorithm, right? So what is it now? So let's call this block Strassen. Block Strassen multi. You have A and you have B. Okay. Start. So first of all, divide. Divide in the sense form the blocks. A is equal to A1 to AK. This just means you identify these matrices. Okay. B is equal to B1 to BK. That's the first step. Then what do you do? For I is equal to 1 to k, for j is equal to 1 to k, form a new matrix. Okay, let's call this P I J. Okay, P I J is equal to, you multiply using Strassen. That's all. So I think the algorithm is called Strassen multi. Check whatever that name is. Strassen multi AI comma BJ. Okay, and for okay. After that, what? You're nearly done. You just return the matrix P, which is the array of those Pij's. So P11, P1k up to PK1, PKK. That's all, and then stop. That is the algorithm. Okay. Clear? So here is where you're using the Strassen multi-algorithm. Now the next one is very similar, so I'll just write it down quickly. Next one is in fact even easier. N cross Kn and Kn cross N, right? So let, now A will be of this form, A1 to AK, and B is of this form, B1 to BK. So AB, what is this? This is A1 B1 plus dot 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 up to AK BK. You understand? To compute each of these AI BIs, you will have to use Strassen multi, and then you just have to sum them. Okay, so complete the algorithm now. Okay, from here it is easy. Complete the algorithm. Okay, very easy. All right. So what is a runtime? What are you really doing? You have actually applied Strassen algorithm k times. Okay, so basically the runtime is Strassen algorithm's runtime times k. That's all. So runtime is just order k times runtime of Strassen, which is n to the log 7. That's all. Okay, there may be other factors in between, but they are smaller than k times n to the log 7. So when you take big O, they will all go inside. So this is it. Runtime is just k times n to the log 7. Okay. Okay, so third one. So you are given two complex numbers, a plus bi, c plus di. I is the square root of -1, as you know. Now you want to multiply these two complex numbers, but you are allowed to use only 3 multiplications of real numbers. You can use addition, subtraction as much as you want, but you can only use 3 different multiplications. Only 3 products can be computed. And how do you do it? Using only 3 multiplications. So what does it mean to have two complex numbers? You are given A, B, C, and D. That is the meaning. Okay. The output should be the real part and the imaginary part. Real part is AC minus BD, imaginary part is AD plus BC. That we already know. Okay. So how do you calculate this? Using only 3 multiplications. So try this out. This is actually very easy if you just think about it for a moment. Try it out. This is not a difficult question, it's more like a trick question. Okay, just think about it. You are only allowed to compute 3 multiplications, but you still have to do this. What is an obvious way? If there is no restriction, then you can do this with 4 multiplications, right? You have to compute AC, BD, AD, and BC. 4 of them. Now you are only allowed 3 multiplications, but as many additions or subtractions as you want. That is the hint. You can use as many additions or subtractions as you want. Okay, so I will not write down the algorithm because this is easy. This is a very simple algorithm. You can write it down on your own. So here's the thing. Given A, B, C, and D. That's what you're given, right? We have to compute A plus BI times C plus DI. Okay, for this real part is equal to AC minus BD imaginary part is equal to AD plus BC, right? And now here's a trick. Now let me subtract these two products and add them. Okay, so this is equal to AD plus BC plus AC plus BD minus AC minus BD. That's all. Is that okay? Now if you look at this, AD plus BC plus AC plus BD is exactly equal to A plus B times C plus D. Check. Okay. Minus AC minus BD. And that is your answer. So what products do you compute? You compute. So compute, let's call it prod 1 is equal to AC. Prod 2 is equal to BD. And the third multiplication is A plus B times C plus D. You are allowed to do as many addition subtraction as you want. Okay, then the real part is equal to, what is this equal to? Prod 1 minus prod 2, and the imaginary part is just equal to prod 3 minus prod 1 minus prod 2. Okay, this is fine because you are allowed to do as many addition subtractions as you want, so this is okay. So is this clear, everyone? It's just a trick question basically. Okay. All right, so we are done with these. Okay, now write a divide and conquer algorithm. Question number 4. Write a divide and conquer algorithm for finding an element in a binary search tree. Okay, so I'll not solve this question. Instead, let me tell you this. Go back to the lecture where we saw binary search tree. I already gave you an algorithm. I may not have written it down. I already explained an algorithm to find an element. Binary search tree helps you to look for an element and say whether the element is there in the tree or not there. There's a very, very simple algorithm. I've already explained it in the lecture. That is the same algorithm. You just have to write it in a form of divide and conquer. That same algorithm, try to write it in a divide and conquer form. Okay, that is your exercise. It's the same algorithm basically, but you just have to try and see how you will divide and repeat the same idea. Okay, so same algorithm, write it in divide and conquer form. This is the big hint for you. So go back to the lecture, look at binary search tree, look at that algorithm and try to write it down in this format in terms of divide and conquer. Is that okay? So it is close to 10:30 now, so I will stop here right now, and then the remaining parts we will look at it on Thursday. Okay, so tomorrow again we will not meet. We will now meet on Thursday. Again, Thursday 8 o'clock or 8:15 we will start. 8 o'clock we will start. Let me see. If I'll get late, I'll tell you. So we'll start at Thursday 8 o'clock and then continue again like this with some more questions. Okay. So meanwhile, you have problems to finish. Okay. Here itself in between, I've given you some exercises. You have to try to write down the formal algorithm for all of these. Some of these in between, I've left them some parts as exercises. This question, divide and conquer, I've already done it in some form. You have to write it down properly in this format. It should look like a divide and conquer algorithm. Okay, and then tutorial 4, so tutorial 6 we have nearly completed. Tutorial 7 on graph algorithms. I will send you a PDF of some graphs on which you have to try the questions. Okay, tutorial 5, think about question 5, 6, 7 and 8. And then tutorial 4, try to complete, try to think about the remaining questions. Okay, tutorial 4, some questions are remaining. Try to think about those as well. So that is it. We will now meet on Thursday at 8 o'clock, day after tomorrow at 8 o'clock. Okay, so I will stop here now. Thanks. Prakash sir is here. Sir, something you have to say or shall I leave? Okay, so I'll leave now. So yeah, thank you.
Thank you, sir.
lecture की meeting